All right, we are going to look at DSMA 9, factoring trinomials, but when we have a leading number in front of the x squared. So these are the hardest ones to factor. For the bulk of these, I'm going to do the same problem two different ways. I'm going to do the box method, and then I'm also going to do what we call the AC method. If you want to practice more of these, you can go to khanacademy.org and you can type in factoring. You can say the AC method, you can say the box method. Another method is the asterisk method, which is kind of interesting too. They really all start the same way. It's just a different way to organize. All right, so the first thing we're going to do is practice a little of what we call factoring by grouping. If we have four terms, the first thing we're going to try is factoring by grouping, because if factoring by grouping works, that's the easiest way to handle these. However, if the factoring by grouping doesn't work, then we have other tools, and we're going to do that in Chapter 3. So what happens with factoring by grouping is we are going to look at the first two terms together, and we're going to work with the last two terms. Okay, and so with these first two terms, the x cubed minus 6x squared, we're going to look at these two terms and see what they have in common. Well, number-wise, they only have a 1 in common, so that won't work, but we can pull an x squared out of there. So we're going to look for the greatest common factor and then see what we have left. Well, we would have x minus 6 left. Okay, now that we've done that, we're going to look at the other two terms. So we have a 3x minus 18. So it looks like I can bring a positive 3 out of there. No x's because the 18 doesn't have an x. So if I pull 3 out of both of those, sure enough, I get x minus 6, right? 3x divided by 3 is x. Negative 18 divided by 3 is negative 6. So now that I've done this, this is kind of like some other problems we did, I think it was DSMA 7, where we have a binomial is what's now in common to both of these. So I'm going to pull that binomial to the front, and then I'm going to grab what's left. So what's left is the x squared plus 3. Okay, so I grouped them into two pieces, and I looked at the first two terms to see what they had in common, and I pulled that out. That was the x squared. Then I looked at the second two terms, again, seeing what they have in common. Well, their greatest common factor was 3, so I pulled that out, a positive 3, pulled that out, and I ended up with x minus 6. Now, at this point, if these binomials don't match, we have to use different tools. But for this section, the binomials will match. So we have x minus 6 and x minus 6. So I was able to bring those forward because those were in common. And that left me with x squared plus 3. Now we do still, because we have an x squared here, we need to check to see if we can factor further. But this one's not going to work because it's not even a sum of squares, although we could make it work. But since it's x squared plus a number, we cannot factor this further. Therefore, that is my answer. And if you FOILed and multiplied those back, you would get back to the original. X times x squared would give me x cubed. They might be out of order. X times 3 gives me 3x. Negative 6 times x squared gives me the negative 6x squared. And finally, negative 6 times 3 gives me the negative 18. All right, let's try this one. Now, I know at first glance, you're thinking, wait a minute, those two middle terms are like terms, let's add them together. But we don't want to for this one. We want to do the factoring by grouping, and so we do not want to add those together at this time. So we're going to go ahead and look at the x squared plus x. Look at what's in common to both of those. Looks like just an x, so I'm going to pull the greatest common factor of x out of there. That leaves me with x plus 2. Then I'm going to look at the next two. Now, something we haven't really talked about, but if the first term is negative, we are going to pull a negative. So no matter what we're working with, if the first term is negative, we are going to pull a negative out of there. So we can see that there's a 4 in common to both of those, but we are going to pull the -4 because the first term is negative. Now you have to really be careful with your signs. -4x divided by -4 gives me x, and then -8 divided by -4 gives me a +2. All right, so let me rewrite that up here of looking at it as far as pulling it to the front. If I pull a -4 to the front, I'm going to divide by -4 here. I'm also going to divide by -4 here. And so that's why I end up with x plus 8 on the inside. Okay, so now we have a binomial in common. We have x plus 2 on both of these. So we'll put x plus 2 in the front, and then we'll grab what's left. What's left is x minus 4. And we're done. We don't have any exponents, so we can't factor any further. We are done. We could check our work by foiling. I will let you guys do that. But that is our answer. Okay, let's take a look at another factoring by grouping. Again, we have the 4 terms, so we're going to take these 2 by 2. We'll look at the first 2 and let's see what's in common. Well, we have a 5 and a -2, so there's nothing there, but we have x cubed and x squared. So we can bring an x squared out. That leaves us with 5x minus 2. All right, and now we're going to look at these 2. Since the first term is negative, I know that I'm going to pull a negative. And with 40 and 16, let's see, the largest number that can go into both of those is 8. So we're going to pull a -8 out. We can't pull any x's out because 16 doesn't have an x. So let's see, -40x divided by -8 would leave me with +5 and an x. And then 16 divided by -8 would give me a -2. So we have to really watch our signs there. Okay, so now we have a binomial in common to both of them. Both of them have the 5x minus 2. So I'm going to pull that to the front. Now, if you learn to just pull it down, that's awesome. The order doesn't, I should have said that on the other slides. The order does not matter because it's multiplication. Let me show you just a second. So I pulled the 5x minus 2 to the front, and I was left with x squared minus 8. Now, since 8 is not a perfect square, we are not going to go that next step right now, even though it's a difference. And I could technically use the square root of 8. We're not going to do that. We're going to stop there. So this is our answer. But it would be just fine if you have it the other way around. If you had x squared minus 8 times 5x minus 2, that works too. Because in multiplication, order doesn't matter. I can have whichever binomial first. So whichever way you were taught to do these. All right, one more with factoring by grouping, and then we'll get into the real factoring. So we're going to look at the first 2 terms. I have a 5 and a 3, nothing in common, but I can pull an x squared out. Okay, then I look at the next 2. Because it's the first term's negative, I'm going to pull a negative. Looks like I have a 2 in common to both of those. So I'm going to pull out a -2. -10x divided by -2 gives me 5x. 6 divided by -2 gives me -3. All right, so now I'm good to go. I have 2 binomials that are the same. So I'm going to pull those to the front because that's the greatest common factor to both of those. And then what's left is the x squared minus 2. Again, if you want to write that in the other way, go right ahead. X squared minus 2 times 5x minus 3 will work as well. Okay, here goes. This one is not factoring by grouping because I only have 3 numbers. 3 terms. It's a trinomial. We may use factoring by grouping as we go along, but first I'm going to show you the box method. So the very first thing we do always is check for the greatest common factor. It would be nice if we could pull a 6 out of there. If that middle number had been 12, we could have. But because the middle number is 13, we cannot pull a greatest common factor out. Now, when we were factoring in DSMA 7 and we were factoring trinomials, I don't know if you noticed or not, but the first term, the x squared, only ever had a 1 in front. And so that's why those were pretty easy to factor. We could just do the two boxes that had to sum to negative 13, and then we had to see if find numbers that would sum to negative 13 and then add to the number at the end. But our problem this time is we have this 6 in front. So what we have to do this time is we have to take the 6 here and the 6 here, and we have to multiply these two together. This is A and this is C. Negative 13 is the B in the middle. Okay, and so that's why this is sometimes called the AC method too. All right, so we're going to come over here and we're going to take 6 times 6, which is going to give us the 36. Okay, so we need two numbers that if we add them together, we get that negative 13 that's in the middle. If we multiply them together, we don't want to get the 6 on the end. We need to take the 6 that's in front as well and multiply those two together. And so we need that to equal 36. That's where the 36 comes from. So let's start to break up 36 into its factors. So we could have 1 times 36, 2 times 18, 3 times 12, 4 times 9. Looks like I got there. I don't think I have anything else left. Okay, so I'm going to look down. These are all the different ways that I can multiply and get 36. But I want to sum, I want to add these two numbers together and get 13. Oh, but I need negative 13. I'll deal with that in just a minute. So if I add 1 and 36, I get 37. That doesn't work. 2 and 18 is 20. 3 and 12 is almost there. I get 15. And then 4 and 9, I get 13. Well, I need negative 13. And so I would need a negative 9 and a negative 4 here. But that's okay. So if I have negative 4 plus negative 9, I get negative 13. And negative 4 times negative 9, you can hardly see that green, you get positive 36. Now, I would like to say we were done because that's how it was in the problems in DSMA 7. But the reason we're not done is because we have that 6 in the front. And so we have to use some method. We either have to use AC method, I'm going to show you that one in the next page, or we use the box. My coworker, Mr. Syme, convinced me of the box. So I'm a believer now, but I will still show you the AC method. Okay, here's how the box works. We always put, and you can use the box for the ones that we did in DSMA 7 if you start to like the box. All right, so we have 6x squared. That's my first term. So the first term always goes in this first box. The last term goes here. So this is an always. So the first term goes in the upper left-hand corner. The last term goes into the bottom right-hand. Okay, now we're going to grab the two numbers that we found. So we found negative 4 and negative 9, but we need those to have an x with them, right? Because if we add them together, we need it to equal this negative 13x that's up here. Okay, so those two are what go in the boxes that are left. It does not matter which one you put where. It absolutely does not. I didn't believe it when he first showed me this method, and I did like 20 of these, and it truly does not matter. So I'm just going to put the negative 4x here, and I'm going to put the negative 9x here. Okay, so the first term came in this first box, the last term came into this last box, and then catty corner here, I put what I found from my analysis over here. So I'm going to put the negative 4x and the negative 9x. Again, does not matter which way. Okay, now the most important part. Now we're going to do a few of these. So at first it looks really, really horrible, but it starts to look better after a little bit. Okay, so we are going to pull, what we're going to do is look for the greatest common factor for each row. So first I'm going to look here, and I'm going to look at the 6x squared and the negative 9x, and I want to know only the greatest common factor. Well, 6 and negative 9, the greatest common factor would be 3, right? 3 goes into both of those. I'm not going to grab the negative unless the first term is negative. And then I have x squared and x. Okay, so that means I would get x. All right, then I'm going to look at the next row. So the next row, I have a negative 4x. So I know I'm going to pull a negative. I have 4 and 6, so they have a 2 in common. The 6 doesn't have an x, so I'm done. All right, now we're going to work on each column, and the same thing. We're going to pull the greatest common factor. So let's look at 6x squared and negative 4x. We're looking down. So the first number is positive. I'm going to stay positive. With 6 and negative 4, I have a 2 in common. And then with x squared and x, I have an x in common. So I'm only looking down this first column. All right, and then I'm going to go to the next column. So I'm going to look at negative 9x and 6. Well, my first term is negative, so I know I have to pull a negative. And then with 9 and 6, I have a 3 in common. And that's it. Okay, so I'm almost done. My answer is actually already here. So this is just a way to organize this. My answer is right here. I have got 3x minus 2 times 2x minus 3. And that, I don't have another color. I wish I had another color so I could make a yay balloon here. All right, so that is factored. So let's come over here and check it though. Okay, so if I FOIL to check it, 3x times 2x gives me 6x squared. 3x times negative 3 gives me negative 9x. That looks familiar. Negative 2 times 2x gives me negative 4x. That looks familiar. And then negative 2 times negative 3 gives me a plus 6. So then I get 6x squared minus 13x plus 6, which is our original answer. So we're checking here. I hope you can see all that on this board. Whew, I know it's kind of messy, but okay, so I am going to do the exact same problem on the next page, but I'm going to show you how it works with the AC method. All right, so here's the AC method, same problem. We first look for the greatest common factor. There's nothing in common. I can't bring anything else out, unfortunately. So now I have to take the number in the front, which we call A, because this is ax squared plus bx plus c. So we're going to take A times c. So 6 times 6 is going to give me 36. And then I'm going to come down here and find all the factors of 36. So I have 1 times 36, 2 times 18, 3 times 12, and 4 times 9. And we need these factors to sum to, oops, I don't want to get in the way here, to negative 13. Let me do this. Okay, we already know they multiply to give me 36, but we need them when we add them together to get negative 13. Okay, so let's rewrite our problem over here. Let me make a box here. So we have 6x squared. Now, instead of the negative 13, I'm going to write negative 4x minus 9x, right? Means the same thing, right? The negative 13x is the same as negative 4x minus 9x. And now I can do factoring by grouping. The box does the same thing for us. It's exactly the same. We still have to find the -4 and the -9. We still have to write all 4 of these terms. It's just that this way you are going to be doing factoring by grouping. Whereas in the box, you have it all organized in the box. So it's up to you. All right, so if I look at 6x squared and -4x, I have 2x in common, and that leaves me 3x minus 2. If I look at -9x and 6, we always take the first term sign, so we're going to take negative, and 9 and 6 have a 3 in common, and that leaves me -9x divided by -3 gives me 3x. 6 divided by -3 gives me -2. And so now I can pull the 3x minus 2 to the front, and that leaves me with 2x minus 3. So I actually get the same answer. It might be in a different order, but remember the order does not matter, right? With multiplication, we're okay with, we could have 2x minus 3 first, and then 3x minus 2, or we can have it this way. So again, just 2 different methods to get the same answer. Let me box the answer. Okay, let's try another one. All right, little bigger numbers. So of course, the first thing we're going to do is see if we can pull a greatest common factor out there, but we can't. We have 5, 6, and 32. So they're not all even. There is no number that's going to come out of all 3 of those except 1. So we're stuck with those. So what we're going to do is take the 5 in front and the -32 on the end. So we are really going to have to watch our signs here. Okay, so we have a little bit of work to do. We have to find all the factors of -160. Some people just see what it needs to be, and that's great if you do. If you don't, we are just going to start working our way down. Now, because this number in the middle is negative, we know that the largest number needs to be negative of our factors. So when I take 1 minus -160, it wouldn't work the other way because when I add these together, I wouldn't get a negative number. All right, 2 times -80, 3 doesn't go in. Let's see, 4 times -40, 5 times, what do I get? 32, 6 times, nope, 6 doesn't go in there. 6 doesn't go in there. 7 doesn't go in there. 8's going to go in there. 8 times 20. I'm going to get there. Oh, here we go. 10 times a -16. All right, so again, all I did was I just kept dividing in my calculator. I divide by 2. If I get integer, then I'm going to take it. If I get a decimal or fraction, I'm not going to take it. Then I divide by 3. That didn't work. I divide by 4. Divide by 5. Divide by 6. That didn't work. I just keep going because I need that. What I need is 2 numbers that when I add them together, I get to that -6 up there. Okay, so I'm going to have to use these 2 down here. Right? If I take 10 times -16, I get the -160 I need. If I take 10 plus -16, I get the -6 that I need. All right, so let's draw our box. We'll draw it down here. Okay, so the 5a squared goes in the first box. The -32 goes in the last box. So always from the original problem, the first term, the 5a squared, goes in this first upper left-hand corner, and then the -32, the last term, goes into this bottom right-hand corner. All right, now I have to put the 10a and the negative 16a. Now, if I forget my variable, it's not going to work because I need these two to sum to give me this negative 6a in the middle. Again, order doesn't matter, so I'll put the 10a here and the negative 16a here. All right, so if I added these boxes back up, I would get the answer of the problem I started with. I would get 5a squared. When I added these boxes that are catty-corner together, I would get the negative 6a, because 10 minus 16 would give me negative 6, and then the a, and then the negative 32 on the end. So now we're going to come over here, and we're going to go row by row and look for our greatest common factor. Okay, so 5a squared and negative 16a. Well, we can't pull any numbers out because 5 and 16 don't have anything in common. The first term is positive, so I'm going to stick with positive, but it looks like I could pull an a out of there. All right, then I'm going to look at the second row, and I have 10 and negative 32. So I think I can pull a 2 out of there. That looks like it's it. The first term is positive, so I'm going to stick with positive. So I think I'm good. All right, so now let's go down each column. So we've got the greatest common factor here and here. So the first column, I have 5 and 10. So that means I can pull a 5, and I have a squared and a. So I can pull an a out of there. The second column, the first term's negative, so I know I have to pull a negative. And then looks like 16 goes into both of those because 16 goes into 32 twice. And so I would have 16. All right, so now what I'm going to do is these are my answers. I have a plus 2, and I have 5a minus 16. So let's write that up here. And order does not matter. We can write it this way. Whoops. Or you can put the 5a minus 16 first and the a plus 2 second. Does not matter because of multiplication. All right, and we're done. I know, it's a lot of work, but hopefully for the most part, we won't see too many of these. Okay, so I'm going to do the same problem for you, but instead of the box method, this was the box, I'm going to go ahead and do the AC method. Okay, so this is the same problem as the slide right before. It's 5a squared minus 6a minus 32. So I looked for greatest common factor first, couldn't find one. So that meant that I had to multiply the 5 in the front times the negative 32 on the back end. And so that was this. That gave me negative 160. Then I used my calculator to see all the factors of negative 160. And I stuck with the largest number being negative because I knew this middle term had to be negative. So I had negative times negative 1 times negative 160, 2 times negative 80, 4 times negative 20, and so on. Finally, I got down here where the two terms, if I added them together, they would get me back to this negative 6a. So I have 10a and I have negative 16a. Now I'm going to rewrite, because this is the AC method. I'm going to rewrite my problem. So I have 5a squared. Now, instead of negative 6a, I can either write 10a minus 16a, or I can write negative 16a plus 10a. It absolutely does not matter. If you want to avoid the signs, we could put the negative 16a first, but it truly does not matter which way we do this. Okay, so now we're good to go. We've replaced the middle term with these two terms, and now we can do factoring by grouping. So if I look at 5 and 16, nothing in common. Looks like I can only pull an a out of there. Then I'm going to come over here and look at these two. I have 10a and negative 32. Well, 10 is positive, so I'm going to leave it positive. Looks like I can only pull a 2 out of both of those. And that leaves me also with 5a minus 16. That's a good thing. So now I have these binomials in common. So I'm going to pull that to the front. And that leaves me with a plus 2. Wasn't a very good arrow there. Let me make this an arrow. I was trying to make it that these two came from there. And that's it. That's my answer. Again, the order does not matter. You can have the problem in this order, or you can write it as a plus 2 times 5a minus 16, because it's multiplication, right? 2 times 3 is 6, but 3 times 2 is also 6.